Hello, ladies and gentlemen. This is Mr. Green, and this is another in the lesson in the series of pre-cal lessons that I am sending you. Today we're talking about, well, let's go back. Last time I talked to you, I talked about a way to use what I called synthetic math to do some stuff to calculate a value without actually plugging the value into an equation. And it was a pretty cool little thing. Well, today we're going to use that same concept and we're going to do some what we call synthetic division. Okay? What I've got here is an equation. 2x cubed minus 11x squared plus 13x minus 21. And I need to make certain that I've got all of my powers represented, all my powers of x. So I got 3, 2, 1, and 0. So yes, I've got them all represented. I'm going to write this in a synthetic division format. All I'm going to do is I'm going to take the 2 from the coefficient here, right here, the negative 11, the 13, and the negative 21. I'm writing them down. I'm going to put this little box here. I'm going to solve this equation right here, x minus 3. Why? Well, we're trying to see if x minus 3 is a factor of this whole big equation. In other words, we're trying to divide this into this one. And to do this, I've got to solve this by saying x minus 3 equals 0. Add 3 to both sides. I get x is equal to 3. So what I'm going to do is I'm going to stick in my box here 3. So when I stick a 3 in here, first thing I do is I bring the 2 down. Not any problem. 2 times 3 is 6. 11 minus, or negative 11 plus 6 is a negative 5. I'm going to multiply the negative 5 times 3, and I'm going to get a negative 15. 13 plus negative 15 is a negative 2. Negative 2 times 3 is a negative 6. And what do I get? A negative 27. What I'm left with down here is really a polynomial, because these are coefficients. Just like these up here were coefficients, these are coefficients. I've got 2x squared. What happened? Well, I'm dividing an x in here, so it's going to be 1 less than this one. So that was a 3, so it's going to be 2x squared minus 5x minus 2. And that's one of the things that would be a factor. Well, kind of. I still have this 27 out here. Minus 27. Oh, that's just like in regular division. It'd be 27 over x minus 3. This would be a factor with x minus 3 as the other factor. Okay? Because I'm getting a fractional portion that would have to be considered in there. Okay? All I've done is write down the factor here now. So let's look at this. Here's another one. I've got all my powers of x represented. I got 2, I got 1, and there's a 0 constant. So I've got 2, 10, and 11. I solve this for x plus 2 equals 0. Subtract 2, and I get x equals negative 2. My little box, negative 2. Bring the 2 down. 2 times negative 2 is a negative 4. 10 plus negative 4 is a 6. 6 times negative 2 is a negative 12. 11 minus 12 is negative 1. My factor becomes 2x plus 6 minus 1 over x plus 2 times x plus 2. Ta-da. So was this a factor of the equation? Was this a factor of the equation? The answer is no, because this didn't divide in evenly, did it? It left me with a fractional portion there. That would not be considered a factor of the equation. What could we use this for? If we're ever asked to factor an equation, all we've got to do is make certain we got all the powers of x in there, write down the coefficients, check for one number as a factor, and solve it and see if we get nothing left here. If we get nothing left here, then we must have a factor. That's interesting. That's an interesting approach to finding factors. We no longer have to just be, trying to do all that factoring and all that stuff when it get even more complicated equations. This synthetic division helps us do it very quickly to see if it is a factor. Now remember, what we were doing the other day, we were actually sticking values in here to try to see if we could wind up with the evaluation. So if this was a function, f of x, what is this x minus 2? When I'm finding it, x plus 2, when I'm saying x is equal to negative 2, I'm finding f of negative 2, right? And what have we done here? We actually evaluated f of negative 2 and found out that there's a fractional portion to it. So it is a value, but it's not the zero value. It's not a root of the function. It's not a factor of the function. Okay? So, how could we go about finding a factor for the equation? Well, we're going to continue looking at this thing. One of the things you have to realize is it has to be a factor of this, of 11. So it would have to be a 1 or 11, right? Well, let's do real quickly. What is f of 1? That would be interesting. So let's just see what f of 1 is. 2, 10, and 11. Guess what? I can tell already my numbers aren't going to get big enough, but we'll see what happens. 2 times 1 is a 2. That's an add those together, I get a 12, and I get a 12 there, and add those together, and I get a 23. Nope, I wound up with a fractional portion, not a factor. Well, I wonder if it could possibly be negative 1. 2, 10, 11. Pull it down, put a 2 times negative 1 gives me a negative 2. That gives me an 8. 8 times negative 1 gives me a negative 8. And 11 minus 8 is a 3. No, but I seem to be hitting all around it, don't I? You can see how it would be possible to continue this process to determine if there was another factor, a factor of this equation right here. Not saying there is, I'm just trying to point out this is the way it could be done. Okay? Same thing here. If I'm looking at this, well, we just checked 3. I wonder if we could use 2. Okay? So 2, we're going to check that, see if it's a factor. 2, negative 11, oops, went off my board. 11, 13, negative 21. And so I'm going to try that one. I'm going to get 2. 2 times 2 is a 4. And negative 11 and 4 is a 7. Negative 7. Negative 7 times 2 is a negative 14. And we get a negative 1. Negative 2 times negative 1, or 2 times negative 1 gives me a negative 2. And I'm not going to get a 0. I'm going to get a negative 23. So it's not a 2. Well, we could keep trying things. One of the things you could try would be, it wasn't a negative 3. You might try a 3. You might try a 7. You might try a negative 7. Because we tried the 2 here. You might try a 1. I'm just trying to give you different things to look for. What am I doing? I'm factoring the first number and the last one here, trying to look for whole number factors. Interesting, Mr. Green. You're using some things that we haven't learned yet. I know. And I am just trying to be a little bit ahead of you. So what you're going to be doing is doing some of that stuff in the future. Right now, any questions, make certain you're sending me K-mails coming to the class, the TOGA sessions, and I'll be glad to talk to you at those times about this. Remember, tell me that you're in pre-cal so I can know and find you a little bit quicker and get your answers to you quicker. Talk to you later.